Hi guys, we're here to talk about soil profiles and soil horizons. So, as always, I will share my screen here with you guys and we'll go through this. Okay, so a soil profile is basically a vertical cross section of the soil. So what that means is if you cut down from the surface and you cut down into the soil, like you're cutting a cake or like you're cutting in to make a road, like a big road cut, or a river cuts down into the soil, and then you can see the soil from the side and you can see different layers within the soil. That is what a soil profile is, just like looking at somebody's profiles, like looking at them from the side. A soil profile is like kind of looking at it from the side, which is not, of course, always a view that you get, and not the view that you get when you look at the soil from the surface. So a soil profile is made up of different horizons, which are these different distinct horizontal layers within the soil. And they are distinct because they look different from one another. And they look different from one another because they have different chemical and physical properties. So they might have different amounts of clay or iron or organic matter or water or oxygen, and they might have different textures, like one might be more sandy or more clay rich, more silt rich, etc. So in the soils here, you can see that there's these different kind of horizontal bands that appear different from one another. And in some cases, they're really distinctly visually separate. And in some cases, it's a little bit more gradual or less extreme. But if you start to kind of get your eyes tuned in, you'll definitely start to notice these differences. So we label horizons with these different letters, so it's not a particular creative way to label them. But the basic makeup of the soil horizons is that there's an A horizon at the top, a B horizon in the middle, and a C horizon on the bottom. And then around that, there's some kind of variation. So there's often an O horizon, which is on top of the A horizon. And that horizon is actually not considered to be part of what we call the true mineral soil. It's really just organic matter like litter and old leaves that have fallen and pine needles and bear poop and other things like that that might be sitting on the surface of the soil. And then in some cases, there's this zone that's called an E horizon that's in between the A horizon and the B horizon. And then below the C horizon is just solid rock, and sometimes that's referred to as the R horizon. So those layers don't really go with the ABC alphabetical line because they're not really the major soil layers of the soil profile. And it's important to note that not every soil has all these horizons in it. So maybe a soil horizon that's in a really desert area doesn't have much organic matter built up on the top. Or many soils are missing this E horizon. This is kind of like a wet, temperate type of soil that would have this built up E horizon. And young soils in particular are often missing the B horizon. So when rock first starts to break down, the C horizon and the A horizon will kind of form first, and then a B horizon will build up after the soil has had, thousands of years or maybe hundreds of thousands of years to develop. So not every horizon is present in every profile. More time, more weathering, faster weathering, which might be due to hotter climates or wetter climates, less topography. If the landscape is more shallow and not as steep, then there won't be as much erosion, so they'll be able to build up more soil quickly. All those things might lead to more soil development, which would lead to deeper and more distinct soil horizons. So I want to go through each of these horizons and talk about some of the characteristics of them in a little bit more detail in the next few slides. Okay, so the O horizon again is just organic matter, dead plant and animal and fungal and bacterial, etc. material that builds up on the surface. It's not, again, considered part of the true mineral soil because it's really not soil. It's kind of like a compost pile on the top of the soil. And in particular, this layer is most significant in forest ecosystems where there's a lot of like deciduous tree leaf and pine needle matter and things like that that fall down on the soil surface each year. This is lacking in many arid environments and also lacking in lots of grassland environments where the grass really forms a layer that covers all the surface of the soil, and there's not a lot of continued other organic material falling from above that gets in contact with the soil surface. So this contributes to a lot of organically derived nutrients in the soil. The nutrients in this essential compost pile on top of the soil will start to break down, and then they'll start to leach or kind of drain down into the A horizon and the other horizons below. So sometimes people break down the O horizon even farther. I don't need you to memorize these numbers for my class, but you may have heard about or come across in the future, or in your textbook it talks about an OI, an OE, and an OA layer. OI is on the surface, that's slightly decomposed, still recognizable, then moderately decomposed, and mostly decomposed. More often you'll come across these terms litter and duff, which refer to this kind of O horizon layer. So litter is like recognizable leaves and pine needles and, you know, bear poop, etc., things that you would actually be able to tell what they are. They're not that broken down. And then below that is this layer that's called the duff, which is really broken down and decomposed. And so it's still organic matter, but it's not something that's easy to tell, like, oh, this used to be a maple leaf or this used to be a poplar leaf. It's much more broken down than that. So anyway, that forms the O horizon that's on the surface of the soil above the first true mineral soil layer, which is then called the A horizon. So the A horizon soil is high in organic acids and organic matter that is leached down from the O horizon above, and also contributed by plant roots and other things and other organisms that penetrate into the A horizon. This is where there's going to be much more plant root activity and much more organism activity. Little earthworms and stuff are going to be moving around in the A horizon, which is sometimes casually referred to as the topsoil. And you're not going to see a lot of earthworms hanging out down in the B horizon or C horizons below. This layer on top tends to be low in clays, which, remember, are those really tiny, fine soil particles, and that's because those little tiny particles are usually washed down into the lower layers of the soil as water continually drains through the soil. And so in some cases, the A horizon is coarser than layers below, but that's not always true. And anyway, you can just see, here's, oh, wrong way. Here's the kind of distinctly dark A horizon that's sitting below the vegetation, below some sort of compost that might be on top of the soil, and then above kind of clayer rich and rockier rich layers that might be below it. Okay, then there's a zone that's called the E horizon. And again, this is not something that's common in all soils, but is distinct in some sorts of usually temperate environments and quite wet soils. So not a lot of soils that we have around here in Plumas County. But the E comes from this term eluviation, which means kind of the movement away from a layer of clays and metal oxides. So it's just a layer that's really washed out, basically. And because it's really washed out, it looks very white. There's just like not much kind of mineral or organic matter left. Well, there's mineral matter left, but it's predominantly like light-colored silicates that are left. And so it has this really washed out look. So it leaves behind these non-reactive minerals like quartz, as I already said. So it kind of has this like light sandy colored look. And then again, this is particularly in these kind of like wet temperate environments where we might have forests. You can imagine areas around like Seattle or Vancouver or like New Zealand, where we might have these kinds of E horizons forming. Okay, then the next real major soil horizon is called the B horizon. And the B horizon is a zone of illuviation as opposed to eluviation. So illuviation is a zone where things are accumulating, as opposed to eluviation, a zone where things are leaving. And so all those clays and metal oxides and organic matter that have been leached out of the layer above are getting washed down and accumulating in the B horizon. And so the B horizon tends to be usually a little bit redder than many of the other layers in the soil. And remember, that's because iron oxide, which might be present in these different kinds of clays, has that rusty color to it. And in a well-developed soil, there may be even more than one B horizon. We might have upper part of a B horizon that's kind of visually distinct from a lower part of a B horizon. Maybe one layer is a little bit more yellow and one layer is a little bit more red, or one is even more clay rich and one's a little bit coarser. So as soils develop and age, they can sometimes have distinctions even within one of these major master horizons. Another term I just wanted to throw out there is called a solemn. So the solemn refers to not the topsoil, which is just the A horizon, but the A horizon and the B horizon together, which really form the main body of the soil. So the C horizon below has a lot more in common with rock than it has with the kind of chemical and physical properties of the solemn soils of the A and B horizon. Okay, so then the C horizon is this layer where soil is forming, but there's a lot of presence of unconsolidated rocky material. So it's not these huge chunks of bedrock that we have below in what we call the R horizon, but there's big chunks of rock that are kind of being broken down around. So this is a picture of a C horizon here. So there's some big rocky pieces and smaller rocky pieces, and then they're breaking down into smaller and smaller mineral fragments. So there's some pieces that we would consider soil size, but they haven't had a lot of chemical, physical, or biological change yet. And so they have a lot more in common with the rock than they really do with like an A horizon, a topsoil. So there's pretty limited biological and chemical activity there. And then finally you get down to the bedrock, which is just this like big solid rock, or in some cases it might not even be solid. It might be a bunch of alluvial river cobbles, but it's kind of a layer where it's pretty much exclusively rock, and there's not really a lot of weathering of the rock that has occurred in that location. So A or O, A, B, C, R, and then sometimes E in between A and B. Okay, so as we start to think more about soil horizons and soil classification over the next couple weeks, you'll often see that soil profiles are labeled with these different layers. And then, as I said, the B horizon especially, but other horizons too, might have more than one layer. So there might be like a B1 layer and then a B2 layer. But then also a lot of times you'll see these little like subscript letters next to the layer classifications, and they are specific codes for certain characteristics of that soil profile. So T, which is a common like little subscript that's included in the soil profile here, represents the presence of lots of silicate clays, which are really common in the soils. And then we won't go through all of these, but Z, as it said, is different soluble salts. So if you have a really salty soil, or you have a P, a lot of plowing disturbance in an agricultural soil, or N, a buildup of lots of sodium, K, a buildup of lots of carbonates, F, it's frozen. It's a part of the soil that's commonly frozen. So if you're in a more like Arctic environment, et cetera, et cetera. So these little letters are these little subscripts that help soil scientists understand a little bit about the characteristic of that layer when they're looking at these soil profiles that have been reported on by other folks. We'll look at this later when we do a lab. We're going to skip that slide. Okay, so some soils, instead of just building on top of parent material that has existed in the same place for a long period of time, are continually disturbed by different kinds of like flood events, or could be like anthropogenic human caused events that continually are depositing more rocky material on top of the soil as it's developing. So alluvial soils, this term alluvial refers to these deposits that are moved by rivers, moved by water. And so what we'll often see along river systems or in floodplains along river systems is that we might have a soil that starts to develop on the surface here. And so we might have an A horizon that's built on top of a B horizon, or sorry, a C horizon, where these like gravels and pebbles that have been washed down from some sort of flood are starting to break down. And it's probably not a really old soil because it's probably deposited relatively recently in the last major flood, so it probably doesn't have a B horizon yet. And then that whole thing might be stacked on top of a whole separate layer that was deposited in a much earlier flood, where soil at that time had been forming on the surface of older rock alluvial deposits. So you might have had an A horizon and a C horizon, maybe a little bit of a B horizon that formed in the middle. And then that whole soil layer was stacked on top of an even older soil layer. So instead of just having the classic ABCR, you might have AC, AC, ABC. So you might have several different soils basically like stacked on top of one another. And then again, this can happen when humans come in and dump like fill dirt or topsoil on top of other soil. And in that case, there's this little like caret symbol that's usually put on the soils to indicate that that's something that's added by humans, as opposed to what we would call the genetic soil horizons, which is like the soil horizons that have really formed in that place. Okay, I think that's a good stopping point.